Hello students, welcome to my channel. In this class our topic is linearly dependent and independent vectors. So let us solve a question. Prove that the vectors v1 is equal to 1, 3, 2, v2 is equal to 1, minus 7, minus 8, v3 is equal to 2, 1, minus 1 of v3 of f are linearly dependent. Now solution. Corresponding to v1, v2, v3, let alpha 1, alpha 2, alpha 3 be the scalars such that alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3 is equal to 0. This implies alpha 1 v1 is 1, 3, 2, alpha 2 v2 is 1, minus 7, minus 8, alpha 3 v3 is 2, 1, minus 1 is equal to 0. So here we have used the values of v1, v2, v3. Now multiplying we get alpha 1, 3 alpha 1, 2 alpha 1 plus alpha 2 minus 7 alpha 2 minus 8 alpha 2. 2 alpha 3 minus alpha 3 is equal to 0. Now adding we get alpha 1 plus alpha 2 plus 2 alpha 3 alpha 1 plus 7 alpha 2 plus alpha 3 2 alpha 1 minus 8 alpha 2 minus alpha 3 is equal to 0. Then this implies this is minus 7 alpha 2. This implies alpha 1 plus alpha 2 plus 2 alpha 3 is equal to 0. This is equation 1. 3 alpha 1 minus 7 alpha 2 plus alpha 3 is equal to 0. This is equation 2. 2 alpha 1 minus 8 alpha 2 minus alpha 3 is equal to 0. Now solving 1 and 2. We get solving equation 1 and 2 we get alpha 1 by alpha 2 by alpha 3 by. This is 1 plus 14. 1 plus 14. This is minus alpha 2 by 1 minus 6 alpha 3 by minus 7 minus 3 is equal to Kc. This implies alpha 1 by 15 is equal to alpha 2 by 5 is equal to alpha 3 by minus 10 is equal to K. This again implies alpha 1 by 3, alpha 2 by 1, alpha 3 by minus 2 is equal to k. This implies alpha 1 is equal to 3k, alpha 2 is equal to k, alpha 3 is equal to minus 2k. This is equation 4. Now putting the values of alpha 1, alpha 2, alpha 3 in equation 3. Then from equation 3, we get 2 into 3k minus 8 into k minus of a minus 2k is equal to 0. This implies 8 minus 8k is equal to 0. This implies 0 into k is equal to 0. 0 into k is equal to 0, which is true for all k. So, taking k is equal to 1, we get from equation 4, alpha 1 is equal to 3, alpha 2 is equal to 1, alpha 3 is equal to minus 2. So, all alphas are not equal to 0. Hence, the given vectors are linearly dependent. Proved. Here, the question is prove that V1 is equal to 1, 3, 2, V2 is equal to 1, minus 7, minus 8, V3 is equal to 2, 1, minus 1. Of V3 are linearly dependent. So corresponding to these three vectors, we are taking alpha 1, alpha 2, alpha 3 are the scalars, so that the linear combination alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3 is equal to 0. Now putting the values of V1, V2, V3, after simplification we get three equations, equations 1, 2 and 3. Now solving equations 1 and 2 we get equation 4. Now putting this value in equation 3 we get 0 into k is equal to k for all k. So now taking k is equal to 1, we get alpha 1 is equal to 3, alpha 2 is equal to 1, alpha 3 is equal to minus 2. So all alphas are not equals to 0. Hence the given vectors are linearly dependent. So our first problem is solved. Let us proceed to solve the next problem. Our second question is prove that the vectors a1, a2, b1, b2 and b2 of f are linearly dependent if a1, b2 minus a2, b1 is equal to 0. Let b1 is equal to a1, a2, b2 is equal to b1, b2. Corresponding to these vectors, let alpha and alpha 2 be the scalars such that alpha 1 v1 plus alpha 2 v2 is equal to 0. This implies alpha 1 a1 a2 alpha 2 b1 b2 is equal to 0. This implies alpha 1 a1 alpha 1 a2 alpha to b1, alpha to b2 is equal to 0. Again, this implies alpha 1 a1 plus alpha 2 b2, alpha 1 a2 plus alpha 2 b2 is equal to 0. This implies alpha 1 a1 alpha 2 b2 is equal to 0. This is our equation 1. Alpha 1 a2 alpha 2 b2 is equal to 0. This is alpha 2 b1. This is equation 2. Given the vectors v1 and v2 are linearly dependent. So alpha 1 not equal to 0, alpha 2 not equal to 0. Now for non-trivial solution, coefficient determinant is equal to 0. This implies a1 b1 a2 b2 is equal to 0. This implies a1 b2 minus a2 b1 is equal to 0. Proved. So here the question is prove that the vectors a1, a2, b1, b2 are linearly dependent if and only if a1 b2 minus a2 b1 is equal to 0. So we have taken v1 first vector, v2 second vector. Corresponding to these vectors, we have taken alpha 1, alpha 2, the scalars, such that alpha 1 v1 plus alpha 2 v2 is equal to 0. Now putting the values of v1 and v2, after simplification we get equation 1 and 2. Here it is given that v1, v2 are linearly dependent. So alpha 1 not is equal to 0, alpha 2 not is equal to 0. Now for trivial solution, the coefficient determinant must be 0. That means a1, b1, a2, b2 determinant is equal to 0. From which we get a1, b2 minus a2, b1 is equal to 0. With this, our second problem is proved. So the topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.